Let us integrate it separately. So we know that 1 by x formation can be written in the form of log x, or 1 over ax plus b can be written as 1 by a log ax plus b. So using multiple angle formula, I can write 1 plus cos 2x and 1 minus cos 2x in the form of 2 cos square theta and 2 sin square theta. We will take x square plus 3x plus 5 is equal to t. Let's derive this. We will get 2x plus 3 with respect to dx. This is equal to dt. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So let's continue the revision of the chapter Indefinite Integral. In this session, we are going to discuss on 3 marks question. So before that, let's see the distribution of marks from this chapter. So in this chapter, you are going to get 4 questions, that is 1 mark, 1 2 marks and 2 3 marks question. Overall 9 marks from this chapter. So let's look at the questions now. Evaluate integral 4x plus 5 divided by x minus 1 x plus 2 dx. So this is a rational function, or we can say it as a rational fraction. So we have learned from the chapter partial fractions to simplify the rational function into 2 or 3 simple fractions. Now after simplifying them, we'll apply the integral and apply the standard integral value. Now before that, let us write this into 2 simple fractions. So 4x plus 5. So we have the factors in the denominator as x minus 1, x plus 2. This can be written as a divided by x minus 1 plus b divided by x plus 2. Let me take this as equation 1. So taking LCM on both sides or multiplying x minus 1, x plus 2 throughout the equation 1, we will get this, that is a into x plus 2, b into x minus 1. Let me take this as equation 2. Now we are supposed to find the constants a and b. For that we have 2 factors. So let us equate it to 0. Suppose if I take x minus 1 is equal to 0, then it implies x is equal to 1. Substitute x is equal to 1 into, then it becomes x 4 plus 5. So a into 1 plus 2 is 3. This becomes 0 because we have taken x minus 1 as 0. So this implies here 4 plus 5 is 9. So 9 is equal to 3a, or we can take a is equal to 3. Next, similarly, let's equate x plus 2 to 0. If you take x plus 2 as 0, then we can take the value of x as minus 2. If you take minus 2 here, then it becomes minus 8 plus 5 is equal to, now this becomes 0. So we are left with b into minus 2 minus 1 becomes minus 3. So this implies here minus 3 is equal to minus 3b, or b is equal to 1. So therefore, now after simplifying this, the integration of this can be written as, substituting the value here, we can write this as integral of, so what is the value of a? We got as 3. So 3 divided by x minus 1 plus, what is the value of b? We have 1. 1 divided by x plus 2 with respect to dx. Now let us integrate it separately. So we know that 1 by x formation can be written in the form of log x, or 1 over ax plus b can be written as 1 by a log ax plus b. So applying that standard integral, let's keep 3 outside. So we can take this as log of x minus 1 plus this one I can take it as log of x plus 2 plus integration constant. So this is the answer, or we can raise x minus 1 whole cube also. Next, second question, evaluate integral of x square into log x dx. So this is the product of 2 function, hence we undergo with integration by parts. I'll take first log function and then algebraic function. So now let us apply integration by parts. First function into integral of second minus integral of derivative of first function, again integral of second function into dx again. So now log x, this can be written as x to the power 3 by 3 minus integral. Derivative of log x is 1 by x. Integral of x square dx is x cube by 3 into dx. So x and x cancels. We can keep 1 by 3 outside. So log x, x cube by 3 minus 1 by 3 integral of x square dx will get. So again we'll get log x into x cube by 3 minus 1 by 3. So again we'll get integral x square dx, that is x cube by 3 plus c as an integral constant. So we can take x cube by 3 outside. You can write this as log x minus 1 by 3 plus c. Next we have integral of x into sin x. Again we are going to apply the integration by parts. First function integral of second minus derivative of first into integral of second again with respect to dx again. So now first function integral of sin x is minus cos x minus derivative of x is 1, integral of sin x is again minus cos x. We have one more dx. So this is minus x cos x. Let's keep minus outside, it becomes plus. Integral of cos x is sin x plus c. Next question. Find integral of 1 plus e power x divided by x plus e power x whole power 5 into dx. So here clearly by observing the numerator and the denominator, we can decide that the x plus ex can be taken as the function t. Any parameter you can take. Now let us derive it. We will get this as 1 plus e power x into dx is equal to dt. Now clearly applying these two in the integral, we will get 1 plus e power x dx as dt, and here we will get this in the form of t to the power 5, which can be written as t to the power minus 5 into dt. So after applying the standard integral, we will get this in the form of t to the power minus 5 plus 1 minus 5 plus 1 plus c, or we can write this as minus 1 by 4 here into 1 divided by t to the power 4 plus c, or we can write this as minus 1 by 4 into, so what is t we have taken? 1 divided by x plus e power x whole power 4 plus c. So this is the integral value. Next question, one more. We'll apply the integral part by here, integration of x into log x dx. Let's keep log function as the first function. So now here first function integral of second minus integral of derivative of first into integral of second again with respect to dx we have. So log x into x square by 2 minus integral of log x derivative is 1 by x, integral of x is x square by 2 with respect to dx. X and x get cancels. We can keep 1 by 2 outside. So we have log x into x square by 2 minus 1 by 2 into integral of x into dx. So we have log x square by 2 minus 1 by 2 x square by 2 will get plus integration constant. So again here we can take x square by 2 outside, we will get log x minus 1 by 2 plus c. Next we have integral of 1 plus cos 2x divided by 1 minus cos 2x dx. So using multiple angle formula, I can write 1 plus cos 2x and 1 minus cos 2x in the form of 2 cos square theta and 2 sin square theta. Similarly, we have 2x here. So let's take here 1 plus cos 2x as 2 cos square x divided by 2 sin square x into dx. Now 2 and 2 get cancels here. So we are left with cot square x dx. So it doesn't have any standard integral for cot square x, but cot square x can be written as cosecant square x minus 1. Now applying the integral separately, integral of cosecant square x will become minus cot x and integral of 1 into dx becomes x plus c. So this is the required indefinite integral. Next we have integral of cosecant x into cosecant x plus cot x into dx. Let's multiply cosecant x inside the bracket, then it becomes cosecant square x plus cosecant x cot x dx. Now applying the integral separately, integral of cosecant square x dx will become minus cot x. And integral of cosecant x cot x with respect to dx becomes cosecant x plus c. So this is the required integral. Next we have integral of 1 over 1 plus cos x dx. So here by using multiple angle formula, or we can say half angle formula, so we can write 1 plus cos x as 2 cos square x by 2 with respect to dx. So when you have 1 by cos square, let me keep 1 by 2 outside. 1 by cos square can be written as secant square x by 2 with respect to dx. So integral of secant square theta is tan theta. So in the place of x we have x by 2 there. So this can be written as 1 by 2 into, so this can be written as integral of secant square ax plus b with respect to dx can be written as tan ax plus b plus c. So here we have 1 by a. Now in the place of a we have 1 by 2. So 1 by a becomes 1 over 1 by 2 into tan x by 2 plus c. So we get cancels here. So we can write this as tan x by 2 plus c. Next we have integrate x square sin x with respect to x. So let us apply the integral part here. So first function integral of second minus integral of derivative of first function integral of second function with respect to dx again. So here we have x square minus cos x minus derivative of x square becomes 2x into minus cos x. Outside we have dx. So we can see we can take 2 outside the integral minus outside the integral. Here we will get minus x square cos x plus 2 integral of x cos x dx. Again we have two functions here. Let us apply the integration by parts again. So we have minus x square cos x plus there also we have 2 first function integral of second minus integral of derivative of first integral of second with respect to dx again. So now here we have x square cos x plus 2 outside x integral of cos x is sin x minus derivative of x is 1 and integral of cos x becomes sin x dx. So here we have x square cos x plus 2 x sin x minus 2 integral of sin x becomes minus cos x. So this becomes plus cos x plus c. So this is the value. Next we have integral of 2x plus 3 x square plus 3x plus 5 to the power 3 by 2 dx. So here we are going to use the substitution method. We will take x square plus 3x plus 5 is equal to t. Let's derive this. We will get 2x plus 3 with respect to dx. This is equal to dt. Now clearly 2x plus 3 dx can be replaced by dt, and x square plus 3x plus 5 can be replaced by t. So therefore this becomes t to the power 3 by 2 into dt, which becomes t to the power 3 by 2 plus 1, which is 5 by 2 plus c. Or we can write this as 2 by 5 x square plus 3x plus 5 to the power 5 by 2 plus c. Next we have here rational function 1 divided by x into x plus 2. We can take this as a by x plus b by x plus 2. So now here we will get this is in the form of a into x plus 2 plus b into x. So if you take x as 0, because we have a factor x here, let's equate it to 0. So if you take x is equal to 0, then this implies 1 is equal to 2a. So a is equal to 1 by 2 we'll get. Now similarly, if we take x plus 2 to 0 here, so this implies x is equal to minus 2. We'll get 1 is equal to, so minus 2b. So this implies b is equal to minus 1 by 2. So therefore, integral of 1 over x into x plus 2 dx can be written as, so 1 by 2 whole divided by x plus minus 1 by 2 whole divided by x plus 2. Now let us apply the integral for this. Now let me keep 1 by 2 outside. Integral of 1 by x becomes log x. Again I will keep minus 1 by 2 outside. Integral of 1 by x plus 2 becomes log of x plus 2 plus integration constant. So we can keep this as log x to the power half minus log x plus 2 to the power half plus c. Or if you want to use the formula of log x minus log y, which can be written as log x by y form, that is x divided by x plus 2. So since here we have to the power half, which is also nothing but the square root, we can keep it as whole power half plus c. Next question, we have integral of x e power x dx. Let us apply the integration parts. First function, integral of second minus integral of derivative of first, integral of second, again with respect to dx here. So we have x e power x minus derivative of x is 1, integral of e power x is e power x, again integral of e power x is e power x only. So the answer is x e power x minus e power x plus c. So for 3 marks question you can expect a substitution method. Major problems you can expect from partial fractions, that is integration of partial fraction as well as integration by parts. So thus we have solved a few problems from this chapter. We'll meet you in the next session with a new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.